Now the third step of these beam problems is finding out the bending moment diagram. If we can work out the bending moment, later on with the equation we'll teach in second year, you can then work out what the maximum stress is. So we've now we're going to do the bending moment diagram. We've done the free body diagram, we've worked out all of the forces which are acting on that beam, we've worked out the shear force diagram. Now we're going to work out the bending moment diagram, because remember, if we're doing a beam in second year, if you know what the bending moment is, then you can work out what the maximum stress is in the system, and that lets you figure out what size I-beam or whatever to use. So what we can do here, we're going to show you a graphical method of doing a bending moment. Graphical method basically is by drawing. This is a way of doing simple I-beams, and lets us figure out visually what's happening. As they get more complicated, you'll go to a more mathematical approach, but let's do a visual. What are we doing when we're doing a bending moment diagram? And the answer is quite simple. What we're doing, okay, we'll draw a zero line on here, is we're doing a running total of the area of the shear force diagram. So what I'm going to do is I go along, I'd add on a little bit of here, I'll add up the area, just like we're doing integration in calculus. I add up the area, and as it goes along, I'm going to get a slope. It's going to gradually increase as I go along. Then it's going to increase a bit more, the slope's going to be different, and then it's going to decrease. And if I've done this right at this point, the bending moment for a free beam that's simply supported by the ends, this should equal 0 when we're finished. So how can I actually do this in practice? Well, actually, let's break this up into 3 areas, because let's do this. So this is area 1, this is area 2, area 3. This is quite simple for this one. We'll do examples with cantilevers and UDLs shortly, and we'll do a more complicated example soon. But what I do is I start at the left hand side, mainly because I come from New Zealand and I read left to right, and I work out the area of each bit, and then I add on the area as a running total. So area 1, sorry, let's use blue, area 1 is going to equal, well, it goes up 20, at this point we're at 20 kilonewtons times 0.5 meters equals 10 kilonewton meters. So I know at this point here, after it's gone this is going to be 10 kilonewton meters. So what I can then do is I can draw a line in, going up from 0 to 10. So that tells me at this point, that area, after I've added all that up, that's equal to 10 kilonewton. I then work out area 2. Area 2 is going to be 10 kilonewtons, area 1, area 2, times, and the distance is going to be 2.5 overall minus that. The distance from there to there is 2 meters. 2 meters equals 20 kilonewton meters. So I've already got 10 here. So 10 plus 20 is 30. So this is going to be 30 kilonewton meters. 30. And that's going to go up there up to 30. And that's right, yep. And so now at this point we're at 30 kilonewton meters. And the last bit that we can do is we add on area 3, which is equal to, well, what's the force here? We're going to add this on. This is negative 20 kilonewtons. Because it's under the line, this is going to be a negative area, so we're going to subtract this. The distance from there to there, 2.5, 4 minus 2.5, this distance here is 1.5, so negative 20 times 1.5 equals negative 30 kilonewton meters. So if I subtract negative 30 kilonewton meters from there, ends up as 0, and it should at the end of this. So this we know is going to go like that. And that is the bending moment diagram for a simply supported beam with two things. This does not include the weight of the beam or anything in this case. We just will do an example with the weight later. Looking at this, I can tell that the area with the greatest bending moment is going to be here. And it's got a bending moment of 30. I can also tell if the greatest thing, if we go along, we often want to know, is an object hogging or sagging? Hogging means if I've got a beam like this, pushing up in centre, then it's hogging, it's going up. Sagging means as it goes along, it hangs underneath. So basically, this is hogging, this is sagging. And what's going to happen is it's going to actually be exactly opposite to this. So basically, as we go along, this beam is going to sag the most at this point here. So if we looked at the beam, it's going to be sagging at this point here a bit, and that's going to be where the maximum moment is, the maximum stress. So we will do some examples with more complicated solutions shortly. We'll do an example with cantilever, we'll do an example with the UDL, and we'll just do next one we'll just do another example with forces like this.